Hey guys, this is Mrs. Harbin, and today we are going to continue talking about statistics and probability. Last class, or in previous classes, we talked about the need for statistics, why we measure data, how we find measures of central tendency, like mean, median, and mode. We also talked a little bit about range. You've been gathering your own data, and now we're going to talk about some ways that we can diagram or show that data in a way that consumers can understand the information that we have gathered. As a consumer, you should be able to read any data that's been diagrammed and understand what it is that you are looking at. Our biblical application is this, that having the right information available is important, but we don't get anywhere if we can't apply or refuse to apply the information. Now, in math, that means understanding the information that we've been given. We've talked about how quote-unquote numbers can lie, or statisticians or other people can represent information and make it sound as if it's maybe more important than it is or less important than it is. We need to be able to intelligently look at data and look at how it's displayed and look at that information before we make decisions. Outside of math, in the spiritual world and in other places, we need to do the same thing. We need to be certain of what it is that we believe. We need to be able to understand information, read information, and come to our own decisions and find information that we're looking for. So let's jump into the math portion here. Today you will read and decipher data from bar and line graphs, pictographs, dot graphs, pie charts, box and whisker diagrams, and stem and leaf diagrams. So lots of information here, but we are going to go through it very quickly. Let's start off by reviewing. Hopefully a lot of this is review what a bar graph is. A bar graph or bar chart is a graphical display of data using bars of different heights. So if you take a look at this, maybe you gathered some information. You did a survey in your favorite type of movie and you found this information. 4 people like comedy, 5 like action, 6 like romance, 1 likes drama, 4 like sci-fi. You can represent that instead of just a list of numbers as a bar graph, and you see that here. We've got our categories down on the bottom, and the height of the bar makes it very easy for us to see very quickly that romance was the favorite type of movie, followed by action, and that the same number of people liked comedy and sci-fi. Drama is way down there at the bottom. So we can see that very quickly by looking at these bars. It's a really good way to show relative sizes, because we can quickly see what type of movie is most liked and least liked. We can also use bar graphs to show the relative sizes of many things, like what type of car people have, or how many customers a shop has on different days or at different times, or so on. So bar graphs, you've been using those for many years. They're just a great way to show information quickly and very visually. Most people understand bar graphs. You might have also seen histograms before, so let's talk about the difference between a histogram and a bar graph. So bar graphs are good when your data is in categories, like the example that we just saw with categories of movies, genre of movies, or information that's different by country or by state. So when we have categories, we want to use bar graphs. When you have continuous data, like numerical data, people's heights or weights, things that change, then we might want to use a histogram. So a histogram is used to show the frequency of a numerical piece of data, numerical data. If you take a look visually, bar graphs have gaps between the bars, so you can see there the different categories are the countries, while a histogram has a number range along the bottom. And maybe this is, showing people's weight and how many people are in that weight category, which might be helpful, in wrestling meets, for example, you have to be in a certain weight category. So bar graphs are good when data is in categories. Histograms are used to show the frequency of numerical data. Our second, or I guess I should say third here, third type of way that we can display data is line graphs. Now, line graphs are graphs that show information that's connected in some way, such as something changing over time. For example, you're learning facts about dogs, and each day you do a short test to see how many facts you remember, and you get these results. Day 1, 2, 3, and 4. You can tell by looking at those numbers that you have improved your memory over time when it talks about facts about dogs, but we can display that data as a line graph. You see our categories on the bottom, day 1, 2, 3, 4, and you can see how it's growing or changing over time from 1 to 4. So line graphs are really good for showing how something changes or grows over time. You might see line graphs that are tracking a population, the growth of a population in a specific spot, specific area or country. We've seen a lot of line graphs as we've talked about numbers with COVID numbers. Line graphs are often used to show the number of people in cases increasing or decreasing and how it's changing over time. So line graphs are great for showing how something grows or changes. All right, let's look at a few more examples here. You've got a bar graph that shows the results when a die was thrown a number of times. How many threes were thrown? Well, hopefully you know. Let's find the 3 on the graph, and we can go to the left there, and our frequency axis tells us that there was 1 3 thrown. This bar graph shows the favorite colors of 20 students in a class. So how many more of them favored blue than those who favored red? Well, first we have to figure out how many favored blue, and we look at our bar graph here, and we see that 6 favored blue. And then we need to know who favored red, and we look at that, and we see that's 2. And the question is, how many more? That wants to know our difference or our range. And 6 minus 2 is 4. So 4 more students favored blue than red. This bar graph shows the usual method of transportation to school for the students in a class. How many students used public transportation? Well, in order to answer this, you need to know what public transportation is. It's transportation that you don't own, that isn't that you're paying for, and it's open to any number of people. So things like a bus or a taxi or a train would be considered public transportation. And when we add all of those categories together, we get that 5 plus 1 plus 2. Well, this says 7 students use public transportation. I would say that 8 students use public transportation. I'm going to count a taxi there as public transportation. All right, 8 students, 5 plus 2 plus 1, 8 students use public transportation. Here's another bar graph that shows the scores that Brett obtained in his end-of-year exams. And if you look at Brett's scores, he honestly did not do very well. In fact, he failed all of his exams, since 70 is a passing score. Brett maybe should have studied a little bit more. What was his combined score on his highest 2 exams? So let's find the highest 2. That would be English and math. Looks like English he got a 60 and math he got a 55, which makes his combined score a 115. If only we could combine our test scores that way. Now, we thought Brett maybe didn't do so well, but it looks like Mark's score was actually lower than Brett's score in science. In fact, it was 15% lower. So we want to know what Mark's score was in science. When we find 15% of something, we're going to write 15% as a decimal. So that's 0.15. And then we are going to multiply that by Brett's score here, which science was a 45. So 15% of 45 is 6.75, I believe. We then subtract that from the science score to find out Brett's score. And when we do that, we see, it's hard to see here, it gets cut off a little bit. That was a 38.25. So 15% of that 45 was 6.75. And take that 15% away from Brett's score, and you get Mark's score. So Mark didn't do so well either. All right, this is a pie chart, which we'll talk about a little bit more in a little bit here. But this pie chart shows the amount of time each day that Jethro spends on various activities. If we were to take this information and display it using a bar graph with hours on our vertical axis, that would be the up and down axis here, what would the height of the bar be for sleep? So along the bottom, we would have our different categories: sleep, work, eat, sports, all of that. And then our hours would be over here on the vertical axis. So we know that sleep represents 25% of each day. And 25% is a decimal of, and then each day. And hopefully you know that a day is 24 hours. So we're going to take 25% of 24 hours to find out how many hours he sleeps. We get 6 hours, so the height of the bar for sleep would represent those 6 hours. All right, we're going to skip these examples here. Feel free to pause and take a look at those because you do need to write some of these examples down, but we're going to move on to the next type of data, which is dot plots. A dot plot is a graphical display of data using dots. Pretty simple. Imagine that you just did this survey of your friends. Again, we've got the same survey with their favorite types of movies here, and we're going to show what they like best. This time, let's use a dot plot. And we've got our different categories like a bar graph, and above those categories we have dots that represent how many people like that category. And I do know that part of this is cut off here. It is very similar to a bar graph. It shows relative sizes, and it's very easy to see which type of movie is the most liked and which type is the least liked. Again, it's very similar to a bar graph, but instead of bars going up like this, you've got dots. So dot plot similar to a bar graph in that you've got your categories and your amounts above it. All right, here's another example. We took a survey of how long does it take you to eat breakfast, and you had the following results. So the number of minutes and the number of people that answered that many minutes. This means that 6 people take 0 minutes to eat breakfast, so they probably have no breakfast. 2 people said they spend 1 minute, so far, so on. It looks like the majority of people take about 10 minutes to eat breakfast here. Just looking at a quick list of the numbers here, but let's represent that as a dot plot. And you can see the numbers on the bottom represent how many minutes, and the numbers above it tell us how many people answered that amount of time. And looking at it, the most people that we have, as we said before, answered 10 minutes, with 7 people who answered that it took them 10 minutes. All right, here is another dot plot. It has the same data as a previous example, but this time instead of showing all of the dots, we just show the highest dot here. So 10 had 7, so we go all the way up to 7 and we put that dot there. 0 had 6, and you can see that dot there. We do need to have lines and numbers on the side on our axes so that we can see what the dots mean if we're not going to put every single dot on there. Right, your next type of way to diagram data is a pictograph. And a pictograph is a way of showing data using images, and each image stands or represents a certain number of things. So here's a pictograph of how many apples were sold at the local shop over 4 months. You can see that 1 apple is representative of 10 apples being sold, so half an apple would be 5 apples. Right, based on that, we can see very quickly that February sold 40 apples. That was the month where they sold the most apples. In January, they sold only 10, so not as many sold in January. This is an interesting way, especially for kids, to represent data. It makes it easy to understand. However, it has a tendency to not be very accurate because we can't show just 1 apple sold or 2 apples sold. It's good for when there are specific numbers like 5, 10, 15. The next way we can show data is a pie chart. And a pie chart is a special chart that uses pie slices to show relative sizes of data. It often uses percentages and shows us the percent of the total answers. So let's use these movie choices survey again and show the data as a pie chart. So the first thing that we have to do is figure out what percent of the total number each category represents. So we do need to know the total for 8, 9, plus 6 is 15, plus 5 more is 20. So 20 people responded. And let's take sci-fi, for example. 4 out of 20 is the same thing as 20 out of 100, or 20%. So we know that this is going to be 20% of our 20% of our pie chart. Comedy is going to be the same. So we do have to do a little bit of changing of our numbers from fractions to percents when we are creating pie charts. It is a good way to show relative sizes, and it's easy to see which movie types are most liked and which ones are least liked at a glance, which one is taking up the most of the information, if you will. All right, let's take a look at this pictograph here and answer how many ice creams were sold in March. Right, hopefully you notice that 1 cone represents 8 ice creams, so we have 8 times 4. That's just some simple computation here, and we get 32 ice creams. How many more were sold in February than in January? Well, February has 8 times 5, which is 40. In January, 8 times 3 is 24. So we've got to take 40 minus 34, and we get that they sold 16 more ice creams in February than in January. All right, we're going to skip this example. Again, a couple of these pictograph examples for sake of time. Feel free to pause and take a look at these, see if you can answer them, or write them down on your notes where you do have to write some examples in your notes. All right, we're going to pause here for part 1 and pick up part